Hey, so I'm doing something a little different today. What I want to do is a mini marathon of radical simplification. So all we're doing is simplify. I have an example on the board here where we just want to simplify the radical as much as we can. If we can't, we can't. And we just provide back the same answer. I'm using my quiz. Got my laptop here. Radical, you probably can't see it, but on the side I got the quiz from the web page. I'll provide a link in the description, and I'll just do as many of these as I say marathon, but the marathon could be like 10 minutes. We don't know how strong a person I am, but we'll find out. So looking at this problem, we have 3 times the 5th root of 64 times the 5th root of 64, and what I can do is I can rewrite this a little bit. Well, since we have 2 5th roots, we can just put it under one radical sign. And I see I already made a mistake by having a pen that's not 100%. So we can write this as, we're at 64 as 2 to the 6th, and then we can write them both under the radical, and then we could write this as adding, we can add the exponents. We get 2 to the 12th. We can put the 5th root of the 12th, so we can just write it as an exponent like this. Then we can separate this out. We could write this as 3 times 2, 10 over 5 times 2, 2 over 5. And 10 over 5, we notice it's just 2. So we're gonna have 3 times 2 squared times, I'm gonna put the radical sign back on this 2 squared. And then just to make it a little nicer, this is a 4, this is a 4, so we're gonna have 3 times 4 is 12 times the 5th root of 4. See if I got that right. My mouse. Yep, got the first one. I think what I'm gonna do is, before I get too far, I'm gonna just replace this pen. Next problem, we have another with the 64 again. We have the 4th root of 64 times the 4th root of 27. Then do something similar. We're going to go to our, write this as an exponent, and write this as, we'll write 27 as 3 to the 3rd. Now this one, so we notice the exponent's greater than the root, so we can take out a 2. We'll split this into 2 to the 4th times 2 squared, and then we'll have the 4th root of 2 squared, which is 4. This 27, the exponent's less than the root, so I'm just going to actually put this back as 27. Then I'm just going to multiply this, so we're going to get 2 to the 4th root. I think that's 108. Yep, got it. Okay, next one. Okay, I already need water. That's not a good sign. I'm definitely no black pen, red pen doing 6-hour videos. So we get 2, the 4th root of 16 minus 2 times the 4th root. Oh, that's just a square root. Gotta be careful. This is square root of 64. There's a lot of 64s in these. Okay, so 16 is just 2 to the 4th. So the 4th root of 2 to the 4th is just 2. So we're gonna have 2 times 2 minus 2. The square root of 64 is just 8. And so this is gonna be 4 minus 16 is minus 12. Let's see if I can do it. I don't want to have to erase the board every time. So let's see, we got 2 times the 5th root of 100. Interesting. I'm not sure what I can do with the 5th root of 100. So 100 can be written as 2 squared times 5 squared. So once you're in a situation where the exponent is not as large as the root, there's not a lot you can do. And this is all, we're simplifying to integers. So I'm gonna say the answer is just this. There's no simplification we can do. That's correct. That's actually why I think these problems are kind of interesting, because even though you may think they're not very hard, you kind of have to think a little about the simplification. And sometimes the simplification is not, it's not necessary. There might be a difference of opinion. What you think is simplified, I might not think is simplified. So some of them are a little sketchy. Generally, you try to get the radical out of the denominator, but some of these answers could be disputed a little bit. For the next one, we have the square root of 125 over 3 times the square root of 256. Now, I know the square root of 256 is 16. So, and I know this is the same as 5 to the 3rd, so let's just do a little rewrite. We get 5 to the 3rd over 3 times 16 is 48. Now, can I simplify a little more? Yeah, because I have more 5. This, square root is 2, second root, so I can take out a 5, and we can rewrite this as 5 times the square root of 5 over 48. Okay, that's correct. Let's see what's next. This is a quick one. 4 times the square root of 25. Okay, that's easy. The square root of 25 is 5. 4 times 5 is just 20. Okay, we got 2 times the square root of 16 minus 2 times the square root of 49. That's pretty straightforward because this is a 4, this is a 7, so we end up with 2 times 4 minus 2 times 7. It's going to be minus 6. Yep. All right, this looks like a little more challenging. We've got the 4th root of 49 times 2. I'll bring the 2 out front, doesn't really matter. Times the 4th root of 125. Ooh, I don't know. So this is 7 squared. This is 5 thirds. I'm almost afraid I can't really do anything. I could write this as the square root of 7. So that's kind of one of those cases where it's maybe a choice, but it's kind of nice to keep. You want to combine the radicals. I don't really want to have 2 different radicals with a different degree on there. I think I'm just going to, let's see, I'm going to use a calculator and see what 49 times 125 is. I don't know that one off the top of my head. So we'll write this as, why did I switch pens? That was dumb. Draw that out. So I'll write this as 2 times the 4th root of 6125, which is 49 times 125. That's correct. So some of these are, the funny thing with these problems is some of them are kind of disappointing. Not every problem is going to be a lot of laughs. It's like some of them are just kind of bland and you just have to deal with it. Next one, we have the cubed root of 25 times the cubed root of 9. Interesting, I think we're stuck again, because this is 9 times 25 is 225, so we end up with the cubed root of 225. This is the same thing as 15 squared, but again, the exponent here is less than this, so I think we're going to say that this is the answer. Yeah, that's right. Okay, next we have 2 times the square root of 36 times the square root of 16. That's just 2 times 6 times 4, 48. Pretty straightforward. Let's see how long it takes for me to make a mistake. So far I'm 10 for 10. Okay, we got a fraction. So we got the square root of 81 over the square root of 25. Again, we can go just square root of 81 is straightforward. 9, square root of 25 is 5. 9/5. Oh, this is extra easy. We have the square root of 36 times the square root of 36. And we could do this in two methods, right? We could do whatever's inside if you multiply a square root twice, it's the same thing as saying you're squaring it, so 36, but we could also square them individually and multiply it out and get 36. Okay, that's kind of overkill. Oh, here's a good one. Let's erase the board. So we got 4 times the 4th root of 512. Now 512 is, don't drop the pen, so 512 is 2 to the 9th. And then I think this is a good case to maybe write this in exponent form. So instead of get rid of the radical, but it's a little easier to see if we write it as 2 to the 9/4. Then we'll just reduce this fraction. Actually, I like to write it like we get the 8/4 times 2 to the 1/4, right? Because when you multiply them, these add together. But then this one right here is just 2 squared, reducing that fraction. And we'll put the radical back on this one. So in the end, we've got 16 times the 4th root of 2. Okay, next one. Let's put this away. Okay, so we have the 4th root of 216. Oh, that's tricky. I don't think we can do anything. This 216 is 6 to the 3rd. And if I take the 4th root of that, there's no simplification. So I'm just going to say no simplification. Here's something I'll do, not on the quiz, I'll do something a little different. We'll do something really similar. Oh wait, I had it. If this was the 4th root of 729, this is a little different, because the 4th root of 729, we could write it like the 4th root of 9 cubed, and then you think, okay, we're in the same boat where you got the same problem we had here. But actually, 9 is 3 squared. So then we don't have that problem, because we can rewrite this as that 9. 3 squared cubed, and then we could write it again as 3 to the 6th, and then we could write it in exponential form like that, which is 3/2. And then we have 3 times the square root of 3. Yeah, that was right. Just showing you it's a little different. the key thing is that there's no, you get the prime factorization, you can't reduce this any further. But with 9, if you do the prime factorization, you get a larger exponent. That was bonus material on the quiz. Okay, next question. That looks interesting. So we have the cubed root of 25 over the cubed root of 125. We could do this, yeah, I think we could do this 2 ways. So 125 is 5 cubed, 25 is 5 squared. So we could write this 5 squared on top, but then this is just 5 as we got the cubed root, right? I don't know why I'm making a big deal of that, but the cube root of 5 cubed is just 5. And then so, but we can't really reduce the top, so we're just gonna end up with 25 over 5. What I was thinking as a different approach is we could take this, put it under 1 cube sign like this, and then reduce the fraction. This is actually 1/5, and then we could write that like this. So then you notice, okay, we have a different answer, right? But to simplify, we really don't want a radical in the denominator if we can help it. So what I'll do is I'll multiply a 5 squared here to eliminate the radical in the denominator. But then this is going to combine to, something just went off. This is just going to be a 5, and then we're back to the answer we had above. So no different. This way is clearly longer, right? You can kind of see all the more work. So that's the long way. Okay, next one. We got the cubed root of 8. I got 2 out front and a cube root of 216. Oh, I like this one. So it's just gonna be 2. The cube root of 8 is also 2. The cube root of 216 is 6. And so this is gonna give us 24. Okay, next we have the cube root of 27 times the cube root of 81. Oh, that's not too bad, but it's a little twist. So cube root of 27 is just 3. Now the cube root of 81, we'll write this as 3 to the 4th is 81. Then we can break that down further. We can write that as 3 to the 3rd times 3. But then this is just going to be, this piece is just going to be 3 when we separate it. So we're going to have 3 times another 3, which comes from here. And then we're going to have the cube root of 3. So we end up with just 9 cube root of 3. I think it's confusing just because of all the 3's. Otherwise it wouldn't be so bad. Oh, this is a good one. We got 2 times the 5th root of 21 minus 2 times the 5th root of 21. It's a good thing we don't have to calculate the 5th root of 21. We just know that these two things are the same, and so it must be 0. Next, we have cubed root of 16, 2 times the cubed root of 36. Oof, that looks pretty hard. Yeah, that looks tricky. I'm not sure what to do with that. This is where these ones get you. I mean, maybe there's really kind of nothing we can do. Let's see. So we have well, this right here is 2 to the 4th. This right here is 2 squared times 3 squared. So we have a real problem there, and then that's not great because that's in our denominator. We could try to simplify the top as we have an extra, if we write this as 2 4/3, then this becomes 2 times the cubed root of 2, just simplifying the numerator. But then on the denominator we can't do much. We'll kind of skip it over here. We'll bring this 2 over, and we'll have the cube root of 36. These 2's cancel, so it seems like we kind of got somewhere. But then we're kind of stuck. We can put it under 1 cube root as 1/18. That's going to be the same thing as 1 over the cube root of 18. So it's simplified, but we don't want that in the numerator, in the denominator. So what I could try next, just to try to make that go away, is I can multiply by a cube root of 18 squared. And then that way we get 1/18 cube root of 324. I think that's the best I can do. This is the first one I got wrong. All right, so let's see. The answer we have in the quiz is 1/6 cubed root of 12. Where did I go wrong? Wait, so 324 is 18 squared, which is 9 times 2 squared, which is 3 to the 4th. Oh, that's where they get you. 3 to the 4th inside of a cube. Okay, wait, so let me take this and keep going. So I didn't simplify it enough. So if we write this out as 3 to the 4th, 2 squared, and then we'll separate terms. We'll separate our 3 and our 2. Then this piece becomes 3 square root of 3. Okay, so then we end up with 3/18. That's not equals 3/18. And then we have this 3 and this 4, so we end up with cube root of 12. And then when we reduce this fraction, see, that's why these are a little bit trickier than, it's a small point because this is the same value, but the simplification can kind of sneak up on you. Next one, cube root of 125 over 3 cube root of 36. Okay, so the top is, this thing is the 5 cubed. So we're just gonna have a 5 on top over 3, and then we have this cube root of 36 in the denominator. Now 36 is 6 squared. So what I can do is bring it over here, kind of separate this out. We just want to rationalize this, get the radical out of the denominator. So we'll just multiply, emphasize the 1, right? Because we want the exponents to add up, and we multiply them. 2 plus 1 is 3, and then we'll be able to pull a 6 out. So then this bottom, this denominator is 6, that we'll multiply by the 3, and we get 5 over 18 cube root of 6. That's a pretty good one. Let's see how we did. Okay, we have, for the next one, 4th root of 81, 2 times the 4th root of 81. We could do this a couple ways. I think what I want to do, let's actually square it. So if we square it, we end up with, we get the square root. The square root of 81 is 9, but we've only reduced to a half. We can do the same thing here. The square root of 9 times the square root of 9 is 9, and then we have 18. If that was too confusing, what we could do, we could write this as this is actually 3 to the 4, 3 to the 4th, 3 to the 4th. And so we could write this like this, and then we just have 18. Okay, we have 2 times the square root of 36 times the square root of 216. Interesting. So we don't know what the square root of 216 is, but we can rewrite this a little bit. Let's write it all under one radical, maybe. I mean, we could do this one a couple different ways. 36 is 6 squared. 216 is 6 to the 3rd. So then we have the square root of 6 to the 5th, which happens to be 7776, which I think is kind of interesting. But this probably wasn't the best way to do it. But we can write this as an exponent, so we can write it as 2 times 6 to the 5 halves, which is 2 times 6 to the 4 halves times 6 to the 1 half equals 72 times the square root of 6. This is actually, right, because that reduces to a 2. And so this is 36. 2 times 36 is 72 times the square root of 6. There's actually a lot of choices in that one. Probably be easier to just take this and call this a 6, right? 2 times 6, then pull a 6 out of this. Yeah, that's way faster to just do it that way. Okay, we have 2 times the 5th root of 25 times the 5th root of 81. Let's make sure the video's still going. Yep, we're at 30 minutes. Okay, I set my goal. I have 20 correct on here. So what I want to do is I want to get to 26, and then I'm calling it good. And then I can call it a marathon, I guess. Even though a marathon isn't usually going to be 40 minutes. But okay, for this one, we can write this as 5 squared. And we can write this as 3 to the 4th, but these are 5th roots. So you see we factored to primes and we're less than the radical. So I think we're out of luck here. I'm trying to think I think that's 2025. Did I do that right? Let's see if I did that right. Yep, 2025. The hard part was multiplying 25 times 81. Next one, square root of 9 times square root of 256. That's just going to be, square root of 9 is 3, square root of 256 is 16. So that's going to be 48. Oh, here's an easy one, but it's kind of fun. Square root of 64 over 3. square root of 64. 1/3. You could do the square root. You could do it a different way. You could square root of 64 is 8. Square root of 64 is 8. 8 over 24, and that reduces to 1/3. Just making things harder on myself there. Okay, we got 4 times the 4th root of 16. This is 2 to the 4th, so the 4th root of 16 is just 2, so we end up with 4 times 2. This is 2 to the 4th. And that's just 8. Oh, I forgot to hit, I've got an inaccurate count going because I forgot to hit enter on the last one, so it's still showing I'm only at 22. But I still have to keep, I gotta see it hit 26 because I promise, so I'm committed now. 4th root of 8 times the 4th root of 16. Well, we just did the 4th root of 16, that's 2. And then we have the 4th root of 8. That's just 2 to the 3rds, but we can't reduce that. So I think this is going to be our answer. Okay, we got a smaller problem. We got the cubed root of 16. What I'll do is I'll rewrite this as the cube root of 2 to the 4th, and then writing it as an exponent, that's just going to be 2 times the cube root of 2. Cube root of 64, oh, that's not a cube, that's a 6. Okay, so cube root of 64 over cube root of 9. I think the cube root of 9 is going to be our problem. The cube root of 64 is just 4. We'll write this one as 3 squared, and then we just need to rationalize the denominator. I'm not even sure if I'm using the right, I don't know if when I say rationalize denominator, I'm not sure if that even makes any sense. Maybe I'm tired and making up words. But either way, we want to get the radical out of the denominator. So we'll multiply like this. This is just going to be 3 when we multiply that out. And we end up with 4/3 cube root of 3. Okay, we're at 25. This is the last one. If I get it right, so we got the 5th root of 8 over the 5th root of 4. So we can rewrite this a little bit. We got the 5th root of 2 cubed. We got the 5th root of 2 squared. Now, because again, exponents less, we can't reduce either of these, but we can put it all under one radical and divide, and we end up with the 5th root of 2. It's kind of nice. Let's see if I got it. Yes, that's 26. Just looking if there's something. Oh, okay, this will be our last one. This is good, the bonus question. So we have the 5th root of 32 times the 5th root of 256. Well, 32 is just 2 to the 5th, so I'm gonna just take that out of the way real fast, and that's gonna reduce to a 2. Now we have the 5th root of 256. 256 is 2 to the 8th. I can write that as an exponent. 8 over 5. But we can write that a little, we can simplify it like this, right? Because when we multiply this together, we add exponents and we get 5/5 plus 3/5 is 8/5. But this is just a 1. So we end up with 4 times 2 to the 3rd, right? Putting this back together again as a radical 5th root, but that's just going to be 4 5th root of 8. That's it. So that's the set 27. It's probably not an accurate count. We probably went over because I think I skipped a few, but it's at least 27. Well, I got some wrong too, so that's approximately, we're gonna call that approximately a radical marathon. I'm actually pretty tired, so I'm gonna stop it.